These are the notes for Thursday, January 14th. We're taking a look today at three new items, both postulates and theorems, ASA, AAS, and HL, hypotenuse leg. And we're actually going to do the proof of the hypotenuse leg. First one is the postulate 4.3, which is angle side angle. It's the one, and you can look at the diagrams and see the figures. It says if two angles and the included side of one triangle are congruent to two angles in the included side of the other triangle, then the two triangles are congruent. By included side, we do mean the side between the two angles. I do have those marked. This is, since it's a postulate, it's one that we accept to be true without proof. If you need a little convincing, just think of it this way. If two angles of a triangle are congruent, then that means the third angles have to be congruent also, because they add up to be 180. We've already talked about the third angles postulate, so by following that. And so we know all the angles match up. There is no AAA theorem or postulate, but when we know the one side, the side between these two angles, the side will determine how big or how small the triangle itself is. So the angles all match up and are of the matching, corresponding parts match or in equal, or have the same measure, let's just say it that way. And then that one side that's between the two given angles determines the size of the triangle, so it makes the two triangles congruent. So you can add the ASA postulate to your list. The next one is the angle side theorem. This is, since it's a theorem, it is one that needs to be proven. We're not going to do a formal proof, but I will walk you through the logic on this. It says if two angles of one triangle and the non-included side, so non-included means the side that's not between the angles, are congruent to two triangles and the non-included side of another triangle, then the two triangles are congruent. So here's how the proof is going to work on this one. I have the angles marked and the side marked that are congruent. Again, this is an informal proof. I'm just going to talk us through it. Since two angles of one triangle are congruent to two angles of another, that means that those third angles are congruent also. So angle C and angle F are congruent. And then if you notice, we have angle side angle in both of the two triangles. So by the angle side angle postulate, the two triangles are congruent. So it's pretty straightforward, and if you would need to write a two-column proof, I don't think anybody would have trouble doing that one. So far, and you need to make a list of this in your notes so you have reference to it, and when you come back to school, I will have it on the board. We have side, 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 angle, side, angle, side, angle, and angle, angle, side. Theorems and postulates. 4 ways we can prove triangles are congruent. There is no SSA theorem or postulate. Doesn't work, doesn't make sense, doesn't work. There's just not enough information there to limit the size of a triangle. I'm going to show the kids in class a picture, but pretty much just for you all that are at home, let me show you how this works. We might have, here's the side of a triangle, here's the side of a triangle. We'll say those two are congruent. We had another side that were congruent. Here we go, here we go. These two are congruent. Here's what happens. We don't know anything about, and I don't necessarily, let me redraw this because I don't know anything about that angle in between, so let me not make them match. We don't necessarily know that those angles are the same or not. Then if the angles that follow, or maybe this angle up at top, if they happen to be the same measure, here's one, here's one, and those measure. So there's SSA. Take a look. If I extend the sides, and this isn't a very good picture because I don't know anything about the length of this third side. I have no clue if it's going to make a triangle, if they're going to meet. And even if I would make this one smaller and it would meet there, if I make this one smaller, because that works even better. Because that angle between the two sides goes off in, because these two do not match, or don't necessarily match, the two triangles, look at them, they're not even close to being congruent, even though we have angles that are the same size and two sets of sides. So this does not work. There is no SSA postulate or theorem. What we do have is something called HL. H stands for hypotenuse, L stands for leg. So, and if you look at the pictures, it kind of looks like an SSA, a side, and an angle. And I guess you could say it is, but it's a particular kind of side-side angle. So we don't say SSA because it doesn't work in general. It only works if the angle is a right angle, and the two sides, one is the hypotenuse. A hypotenuse is the side across from the right angle. The side across from the right angle is the hypotenuse. And then the other two sides are called legs, and you could have either one of those. So hypotenuse says if the HL theorem says if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the two triangles are congruent. What you look for, the must-haves to use this one, you must have right angles in both triangles. You must have the hypotenuse of each right triangle must be congruent, and then you must have a pair of matching legs. Three things that you have to use this theorem: right angles, hypotenuse congruent to each other in the two triangles, and one pair of congruent legs. On Friday, we're going to prove this in class. Let me just go ahead, and it's not going to be real pretty because I'm going to write it with my stylus, but let me just walk you through our proof on this one. All right, so here's where the statements are going to be, because this is a short proof. And here's the reasons. Two-column proof. I like them nice and organized. So first thing, we are given right triangle PQR and right triangle XYZ. We are also told, if you can see by the picture, that PR, actually we don't know that yet. Hold on. Oh, yes we do. If the hypotenuse, so let's go back. We also know that the hypotenuse, because that's part of our hypothesis. So we have, let me say it again. Sorry about that. We know that PR is congruent to XZ, and we need a leg. So we know that PQ is congruent to XY. All of that is our hypothesis that comes from the if statement. Then what we're going to prove is that the two triangles are congruent. So we want to prove that triangle PQR is congruent to triangle XYZ. All right, so let's get everything written down here. Step one, let's just write our given. We have right triangle PQR, and you have to put it all, and right triangle XYZ. And that is given. Now normally we write all the given right off the bat. Okay, I'm going to change it up just a little bit. Okay, I'm going to use this part first. Because this is a right triangle, I'm going to state that angle Q is my right angle. Actually, we can see from the diagram, so we're just going to say angle Q is congruent to angle Y, because all right angles are congruent. We might need that, we might not, but I know that, so I'm going to throw it in there. We're also given that PR is congruent to XZ. Let me write the congruent statements, and PQ is congruent to XY, and that is also given. Now I have to figure out where to go from there. To prove the triangles are congruent, I can't use HL because that's what I'm trying to prove. I have to use something else. So I'm going to show you something that we haven't done in any of our proofs so far, but you can do. Notice that PQ and XY are exactly the same length. So what I can do is I can take, this isn't going to be near as pretty of a picture. Here's my triangle XYZ. And I'm going to redraw PQR so that PQR and XY just match up. I'm going to put them on opposite sides of each other. Since they're the same length, it's going to look a little weird, but I'm allowed to do that. Let me rewrite these. So Q is down here, and also is Y from the original picture. We'll just think of them as being both names. Those sides match up, so I can do them back to back. I still have my right angles. The hypotenuse is still the same length, and I still have that side in the middle. Now, I want you to look at the big tree. When you put them together, it makes a large triangle, and in fact, it makes an isosceles triangle. And because it's isosceles, we know that these base angles are congruent. So angle R is congruent to angle Z, because base angles of an isosceles triangle are congruent. We proved that when we were talking about isosceles triangles. Step 5, we are there, folks. Because now if we look at the individual triangles, we have A, S, A, S. So we can now say that the two triangles, triangle PQR is congruent to triangle XYZ by AAS. I guess I really didn't need step number 2 in there, but because I knew I had right triangles, that was information I knew. I didn't know if I was going to need it or not, so I went ahead and put it in the proof. All right, so that's your proof of the hypotenuse leg theorem. I have an assignment on Canvas. It is identifying AAS, ASA, and HL in figures. Remember, if you use ASA, it has to be an angle followed immediately by a side and followed immediately by an angle. So 2 angles and the side in between. If it's AAS, you're going to have an angle, skip over a side, look at an angle, and then the immediate next side. And hypotenuse leg, you have to have a right angle, a right triangle. Has to be a right triangle. You have to know that the hypotenuse, the side across from the right angles, are congruent, and then a third leg. So it is up on Canvas. Send them email if you have any questions. Hope to see you soon.